Module structure explained. Terraform loads array.tf file in a directory into a single configuration graph. All resources in that directory becomes part of the same dependency graph. A modification to one resource causes Terraform to recompute dependencies across the entire graph. Unrelated resources appear in the plan because the dependency graph must be recalculated globally. Engineers often interpret this behavior as Terraform touching resources arbitrarily. The actual cause is the absence of structural isolation in the configuration. Terraform reads array.tf file in the working directory during initialization. File names and file order have no semantic meaning to Terraform. Terraform merges all blocks into one configuration before building the dependency graph. Grouping resources into different files does not create operational isolation. Terraform only recognizes boundaries created through modules. A module isolates infrastructure logic into a reusable configuration unit. Terraform evaluates module contents as a separate configuration scope. Resources inside the module become nodes inside a subgraph of the main dependency graph. Only explicitly defined inputs and outputs cross the module boundary. This isolation reduces accidental dependency propagation. Infrastructure behavior becomes deterministic because the graph surface area is constrained. Modules receive inputs through variables defined inside the module. The root configuration passes values into those variables. Terraform treats variables as the module's input interface. Only data passed through variables become visible inside the module. Resources inside the module cannot directly reference external resources. This forces engineers to define explicit configuration interfaces. Modules export information using output values. Terraform records output values in state after resource creation. The root module reads those values from state during future plan operations. Outputs form the only supported path for data to cross a module boundary. Internal resources remain hidden unless explicitly exported. Designing outputs determines exactly what downstream configurations can observe. Selecting minimal outputs preserves the isolation created by module boundary. This preserves the watertight compartment while still allowing controlled data flow. The root configuration reads module outputs through the module namespace. Terraform resolves these values from state during plan and apply. Dependencies automatically form when resources reference module outputs. Higher level infrastructure can safely build on lower level infrastructure components. Terraform connects modules through explicit output references in the dependency graph. Submarine systems are divided into watertight compartments. A failure inside one compartment cannot propagate across the vessel. Terraform modules serve the same operational purpose. When infrastructure logic is not isolated inside modules, configuration failures propagate across the entire dependency graph. Module boundaries reduce the blast radius of mistakes during Terraform plan and Terraform apply.